talking about some additional properties of logarithms today. You are responsible for being familiar with and being able to tell the difference between different properties. So kind of mark that on your list of things to do as we prepare for our quiz on Friday, that you're kind of comparing properties. You're seeing when would I use this type of property versus this type of property. So make sure that you're at least familiar with properties for the quiz. Okay. And then you'll be doing problems like we do in our homework. But you should also kind of understand how the properties work. The first property we're going to use is called the change of base formula. Now, you do need to know how the change of base formula works, but we will talk about in our calculators. Some of us no longer need the change of base formula in the calculator because the calculator allows us to put in new bases. That was not always the case. For a long time, the calculators didn't have an option for changing the base of a log, and the calculator only had two buttons, right? Natural log and common log. So in the calculator, you can only do those two logs, especially in your scientific calculator, that's all you can do. In the graphing calculator, some of you may have an updated version where you can actually change the base, and we'll look at that. But either way, you still have to know how a change of base formula works. So if you're taking the log base a of x, and that could be anything. That could be log base 2, log base 3, log base 5, log base 1/2. It could even be log base e or natural log. To change its base, you're going to take a log of any base. In this case, I'm using the common log because there is no base listed. So what is its base? 10. This is the common log. So I'm taking the common log of x divided by the common log of a. Now, it doesn't have to be common log. The only reason I use common log is because common log is on everybody's calculator. Okay. You could also say that the change of base formula is the natural log of x over the natural log of a. So we'll do an example and we'll do it both ways, and you'll see your calculator gives you the same answer for both of them. So basically the rule with change of base is, if you want to change the base of your log, then you take the log of x over the log of a, and that could be any bases as long as the bases match. But we're choosing either common log or natural log because those are buttons on the calculator. So let's look at this example. Log base 2 of 12. If I'm doing that one without a calculator and I'm thinking about it in my head, I'm thinking, okay, 2 to what exponent will give me 12? Well, 2 to the third is 8, 2 to the fourth is 16, and I've completely skipped over 12, so I know it's somewhere in between 3 and 4. I could estimate it for the purposes of graphing, but if I want the exact value, I could use my change of base formula. So the log base 2 of 12 has a base that I don't have a button for that on my calculator, right? So I could choose either the common log or the natural log, and I could do common log of 12 divided by common log of 2. Type that into your calculators for me. If your calculator brings up a parenthesis for your log, you've got to make sure to close that parenthesis for me before you divide. If you divide inside that parenthesis, that's not going to work out. And this works in all types of calculators, not just graphing calculators, so you might have done this last year in Algebra 2. And remember, we already have an expectation of what this is going to be, somewhere between 3 and 4. Did anybody get a number yet between 3 and 4?
3.5.
Okay, so I'm going to say 3.585. I round up 49, you said? I usually go to the thousands place, so that's 3 numbers after the decimal. Okay. Now, if you want to just experiment with this, try natural log of 12 divided by natural log of 2. It doesn't matter if it's common log or natural log, or if it was log base 3 of 12 divided by log base 3 of 2, we will come up with the same answer, 3.585. So that's how the change of base works. Just take 2 logs of the same base divided by each other. Now, if you want to check your answers ever, of course you can do 2 to the 3.585, and it should be pretty close to 12. It's probably 11.99 or 12.001 because we rounded. And then now I'll teach you how to do it in your calculators, and you'll just kind of test your calculator. I'm not sure if the older versions without the color screen have them or not, if they don't have math print. So at least check it and see. Okay, if you type math in your calculator and you scroll down, there should be something that says log base. Yes, click it.
Is it like a button?
No, so you type the button math, and it brings up a menu, and you scroll down on the menu, and there might be something that says log base. If there is, click it. Do you have the non-color version? Yeah. So the older versions that don't have math print can't subscript, so then they probably don't have it. Okay, but some of the newer ones do. Is yours an Inspire or color?
Jesus.
Bless you. On the Inspire, you just click your log button. Someone would just click the log and log it up. And you can kind of play around that type log base to 12 in and see if it works. Okay. 2 to 12. Yeah. Yeah, that's what I'm thinking. Okay. So if you have a question about your calculator, let me know. But now you know what you're responsible for. If you need to evaluate a log with a calculator and your calculator doesn't let you choose the base, then you have to use the change of base formula. But if your calculator lets you choose a base, you're still responsible for knowing the change of base formula and how it works. Yeah. You understand that? I may have a question about change of base formula. Okay, next up. Our last set of properties are probably the properties that maybe you recall from Algebra 2. And we use these properties to do something we call expand and condense. Our product property looks like this. Log base A of u times v, which is a product because u and v are being multiplied, is equal to the log base A of u plus the log base A of v. Now, I remember these logarithmic properties because remember what I said yesterday about logs? Logs are really just exponents, right? Okay, so think about what happens in exponential expressions. If you're taking x cubed times x to the fifth, what do you do to the exponents? Add them. So when you are taking the log of a product, you should add your exponents, which your exponents are the logs of those two things. So that would be x to the 3 plus 5. And for quotient property, the only thing that will change because I'm dividing is instead of adding the logs, I would be subtracting the logs. Now, all three of these properties can go both ways. So we have different set of directions that we use. If we're going from the left, we're taking a product and we're turning it into the sum of the exponents, sum of two logs. That's called expanding. So if you go from left to right, that's called expanding. And if you go from the right to the left, if you have two logs that are being added together, but you put them together in one log, then that's called condensing. So those phrases may sound familiar to you. One thing I always make note of in expanding and condensing with the division or the quotient property is the things that are in the denominator must have negatives in front of the logs. So like if I were condensing the right side, I would see log base A of u is positive, so u is on top, minus log base A of v, so v is on bottom. If I had a minus log base A of w, after that, then I would have v times w in the denominator. Because anything that has a minus in front of the log goes in the denominator. And the last one is the power That's log base A of, I think it's u to the n, is what your book uses. And this is the power of a power property. So if you have something like x to the fifth, and then you raise it to the third, what do you do with those exponents? Multiply them. So what we're saying is, let's multiply our exponents here. One of our exponents is n, and the other exponent is the log, because the log is just an exponent. So we're going to take n times log base A of u. You maybe were taught to think about it like, okay, take your n and drop it in front and multiply. If you're cleaning up, if you are condensing, then you'll take this n and you'll put it back on the u. Now, on a side note, we are going to use the properties. Properties are helpful still because when we're solving equations, sometimes we need the equations to be simplified in some way. So we might need to condense some things together, some log expressions in order to be able to solve for a variable. So we are going to use the properties in a useful way there. Like what you're practicing today, sometimes you might be like, why am I doing this expanding and condensing? What is the point? And remember I had maybe mentioned like a long time ago before people had calculators that they could carry around, they had book of tables. Okay, so this is book of tables. When my parents were moving to Omaha, they were like, oh, we found a whole bunch of math books. Do you want them? Yeah, bring them. Definitely. And then I got this book of tables, and I was like, I've always wanted a book of tables. It's my dad's book of tables, so it smells old. All those things. Maybe like old books smell, you can smell it. Elise must not like the smell of old books.
No, not really.
Okay. I marked a few pages. So one of the orange postmarks is, or post-it note is the actual properties of logs. So they explain like how to use logs, how to expand and condense them. And then if you go to the next post-it, it's like a list of logs. So like if you needed to evaluate a log, you didn't have a calculator that you could type it into, then you would have to look it up in the table. And then you would use that number that's listed there. Okay. And this book has a whole bunch of tables that has like trig function, sine, cosine, tangent. And the fluorescent yellow post-it, those are going to be square roots. Because you didn't have a calculator to do your square root either. So you used a book of tables. So think about how thankful you are to be living in 2018 and you just carry around a calculator, right? Everybody else had to look it up. And that goes back to like some of those reasons like, why do I rationalize my denominator? Why can't I leave it as square root of 3 over the square root of 2? Well, if you were doing it back then by looking it up in tables, you'd be taking like 1.73 divided by 1.41 with a whole bunch of numbers after the decimal. And if you rationalize your denominator, then you just take a decimal divided by 2, which is a lot easier. Okay, so I'm going to pass that around if you want to take a gander there.
Okay, so if we bring one of those to school, are we allowed to use that on the test? Tables?
I would guess, I mean, I don't know, it would depend on your math teacher. If you want to do a book of tables, sure. I'm going to flip through it to make sure you don't have any cheat notes in there. Okay, this little contraption is called a slide rule. And the slide rule is another method that you could use instead of carrying around the table. You would carry around this slide rule. And I don't even know how the slide rule works. Sometimes I look it up on the YouTube before I come to class, but I didn't get a chance to today to figure it out. But I always forget. But if you have a family member or like a neighbor or somebody who is older, I would say like maybe like I don't know, 50 plus, maybe 60 plus. Before carrying around a calculator was like a real big thing, right? I gotta do my math there, and I'm getting older, so it's hard for me to judge. But if you have somebody who was in a math-related field, like maybe engineering, possibly architecture, or they studied math in college, you might ask them if they know about the slide rule, and they can probably tell you a whole bunch of stories. Like I've talked to people who used the slide rule back in the day, and they had like things for their belt where their slide rule was, and they would like pull it out. And calculate things. So I don't know how the slide rule works. I can't do it for you today, but that was another way you could calculate logs. So now we just carry around the calculator, so that's good. Okay, what you're going to be doing next is examples in your groups. So I'm going to give each group a letter. You guys are going to be A, B, C, D, E, F, and G. And then I've got cards up here for each group. So you're going to take the top card from the pile, and like this is group A1, so it always has their number there, and or their letter and their number, so it's the first card. They're going to take this back to their desks. They're going to write this down. They're going to talk to each other and expand. And then they'll send one person to me, and I will check to see if it's right or wrong. Bring your blue card with you when you check it, because if you get it right, you can come turn it in above your pile, and then pick the next card. And you just are going to go through some examples with your groups today. Okay? So go ahead and send someone up here to grab the first card. And get started.
Woohoo!